Hello, class. So we're actually skipping temporarily section 10.7, because it's a little different. Um, and we're going straight to section 10.8 for now, okay? Which is systems of non-linear equations. Okay, so the key term is non-linear, right? What we've been doing for the last, 7 sections is linear systems, okay? So what this means, okay, the non-linear part means that we cannot use any matrix things, okay? Matrices are only for linear systems, okay? So what that means is basically we're back to section 10.1. Okay, so if you remember, in that section, that was when I first taught you substitution and elimination. Okay, so basically we're back to here, except we have to be clever. All right, so here, if I look at this system, right, hopefully you guys can see that there is no way I can use elimination method. Right, like how can I eliminate when none of the variables talk to each other, right? So there's no way I can use elimination. So here I have to use substitution. All right, and specifically, what you should do is you should substitute correctly. Okay, so what I mean is in section 10.1, right, I was like, you can pick any letter you want. You can still technically do that. It's just highly advised that you would pick one of these two. Okay, you should not pick the x squared or the y squared. Because if you pick the x squared or the y squared, right, so let me solve for x here, right, you're going to get this plus minus thing. So then when you plug it into here, you're going to get 3 plus minus square root 100 minus y squared minus y equals, right, you don't want to solve that. Like you can, you should know how to, but that's way too much work. Okay, so that's why you don't want to pick a quadratic term to solve for. All right, so instead what you want to do, okay, is you want to solve for one of the linear terms. Okay, so here, right, I'm going to pick, I don't know, I'm going to pick a y. Okay, so solve for y. So 3x equals 10 plus y equals 3x minus 10. Okay, now what you do is you then substitute that in the y slot, like normal substitution. Okay, okay, and now you can solve this. This is a quadratic equation, right? You should know how to do this from like chapter 3 or 2 or something. Okay, so we can see, right? So let's let's do this. So 9x squared minus 60 x plus 100 equals 100. So the 100s cancel. And you're gonna get 10x squared minus 60x equals 0. So divide by 10. X squared minus 6x equals 0. X minus 6 equals 0. So you get two answers, right? You get x equals 0 and x equals negative 6. Okay, and now what you do is you plug both of those into the y. Okay, but you got to be careful because they're pairs, right? Like when I plug in x equals 0 into y, what happens? Y equals negative 10. That's one pair. Okay, so then when I plug in x equals negative 6, y equals negative 18 minus 10, which is negative 28. Did I do that right? Oh, no, I didn't, because this should be positive 6. So this should be positive 18. So this should just be 8. There we go. And then, so you have two answers, and you must answer this way, okay? 0, -10, 6, 8, okay? Those are your two answers to this system, all right? These 2 points. And if you think about it, this kind of makes sense, okay? Because, right, this should look familiar to you. That's a circle, right? And that definitely should look familiar to you because that's a line. So basically, well, the question I'm asking is, where does the line cross the circle? And the answer is these 2 points, okay? All right. But there you go. Okay, so it's honestly not that much harder. It's just you have to be a little creative at the very start. You have to know how to get your system of 2 equations, 2 unknowns, back to 1 equation, okay? All right, so let's do another one. Okay, here's another example. 3x squared plus 2y equals 26. 5x squared plus 7y equals 3. All right, so this one, you can use substitution. Pretty much you can always use substitution. It's just whether it's recommended or not is a different question. All right, but also here, you notice you have y's and x squareds. Okay, so both of the equations can actually talk to each other, which means you can also use elimination here. All right, which I guess, let me use elimination. Okay, so what I'm gonna do is 5 row 1 and 3 row 2 because I want to get 15. Okay, so 15x squared plus 10y equals 260. Wait, just kidding. 5. Okay, so when I multiply 5 and 26, I get 130. Okay, and then when I multiply this by 3, 15x squared plus 21y equals 9. Okay, now I'm going to do a row 1 minus row 3. And let me go back down to the original row 2 also. So row 1 minus row 3, 0. -11, y, and then 121. Okay, and then go back to the original because I divided by 3. Okay, and then we're done. Sort of, right? I'm gonna stop using elimination now. I'm gonna do like back substitution, right? So you're gonna get y equals -11, and then plug that into here. Okay. So 5x squared plus, just kidding, minus 77 equals 3. 5x squared equals 80. 5x squared equals 16, which means x equals plus or minus 4, right? So remember though, this 11, right, went to both of them, right? So you should have x equals 4 -11 and -4 -11. Okay, remember again what your pairs are. Okay, if you have a plus minus that comes up. Okay, but there's your answer. 4 -11, -4 -11. All right, not too bad. Okay, let's do another example. Okay, so here, x squared minus y equals 2. 2x minus y equals -1. I guess I'll just alternate. So let me use substitution here. So if I use substitution, y equals 2x plus 1. So let me plug that in there. x squared minus 2x minus 1 equals 2. X squared minus 2x minus 3 equals 0. Does this factor? Yes, it does. X equals 3 negative 1. So then when I plug that into y, so if I plug in 3, I'm going to get 7. And if I plug in negative 1, I'm going to get negative 1. Right? So then my answers are 3, 7. And so let me negative 1, negative 1. Ta-da! Okay, great. So most of these you're going to get 2 answers. Sometimes you could get more. Sometimes you could get less. Okay? Very specifically, okay, let's do this one. All right, so this will be like a hard example. All right, so here you might be tempted, okay, to do substitution. All right. If you are tempted to use substitution, your only choice really is the y, right? So what you would do is you would be like, okay, y equals negative 1/2 x squared minus 1/2, right? But then, okay, you would notice, right? You want to plug that in there. You would then square it, right? So you get 3x squared minus 1/4 x to the 4th plus some stuff. Okay? This is an example of when it's a little overly complicated and you should not use substitution. Okay? Because, right, x to the 4th, you kind of might not know how to solve that polynomial that you're going to get, right? You would have to hope that it has rational roots, right? Or that it's a special formula because, right, you can only really solve quadratics. So this is the example of when substitution, probably not the best idea, okay? You should use elimination here, okay? At least first. So I'm going to use elimination first, and so that means I'm going to go up to 6. So I'm going to do row 1 times 2 and 3 row 2. So 6x squared minus 2y squared equals 4. 6x squared plus 12y equals negative 6. Okay. So row 1 minus row 2. And I'm going to go back down. So row 2 divided by 3. So 2x squared plus 4y. Actually, I'm going to divide by 6. What's wrong with me? 6. I could have done that way nicer. Okay, so 2y negative 1. Okay. And then, so okay, so this is 0, so that's the point. So I'm going to get negative 2y squared. And then I am subtracting. So minus 12y equals 4 minus minus 6. So it's going to be 10. Okay. So then, right, this I can solve now. So I'm going to divide by negative 2. So y squared plus 6y equals 5, which y squared plus 6y minus 5 equals 0, which y minus 5 this does not factor. Does this factor? Am I going insane? Oh, I divided by -2. Yeah, divide by -2. So that gives me that. So that's gonna be a +5. And then it does factor. Okay. All right. So you get y equals -5, comma, y equals 1. Okay. So now y equals 1 is what I'm going to plug into this thing. So x squared plus 2 times 1 equals -1. So x squared plus 2 equals -1, which means x squared equals -3. Is this right? Have I gone crazy? Uh, oh yeah, I've actually gone crazy. -1, -1, -1, -2, +3. All right, so x equals plus or minus square root 3. I'm a bit confused and or concerned. I am a bit concerned. Is that right? So then, like, right, so then I'm supposed to get these as answers. -3, -1, square root of 3, -1. All right, I'm gonna check if that's right. So I'm gonna plug it into this thing. So right, okay, so x is the square root of 3. So I'm gonna get 2 times 3 plus, well, -4, right? Because y is -1. So 6 minus 4 is definitely not -2. Okay. Now, have I actually lost my marbles? I actually have. What is wrong with me? All right. I should actually just redo this entire video to save myself the embarrassment. But continuing on, if you probably fast forwarded to this point, okay? If you fast forwarded here, good job. All right, I encourage you to have done that and not just watch me struggle for like a solid minute. All right. All right. So you get plus minus 1. So 1, -1, comma, -1, -1. All right. If you plug that into here, it works. All right. So if as long as you actually know how to subtract, right, because 2 minus 4 definitely is -2, okay, then you will be correct. Okay. All right. Now, you just do this all over again. So plug in y equals -5. So x squared plus 2 times -5 equals -1. X squared minus 10 equals -1. This time, add 10 to both sides correctly. All right, so then I'm going to get 9. And then you're going to get plus or minus 3. Okay, so you should get the two other answers, 3, -5, -3, -5, which are correct. So the final answer to this one is 1, -1, -1, -1, 3, -5, -3, -5. Okay. Alrighty then. So you can get more than 2 answers. You can get like 1, 2, 3, 4, 5. Literally, it doesn't matter. You will just get, answers. Okay. Now, just to finish off, one more example, and then we're done with this section. All right. So this last example will be way smaller, thankfully. All right. -x plus y. I just need to show you it. So I'm going to pick substitution because it's easy. So, right, I'm going to solve this bottom one for x. So x squared minus x equals -2. X squared minus x plus 2 equals 0. This, you notice, after you try a little bit, this does not factor. Okay? So, quadratic formula, right? Negative b plus or minus the square root of b squared minus 4ac, so minus 4, so minus 8, all over 2a. So the answer is -1 plus or minus the square root of, right, -7, right? So I square root 7 over 2. Right, and then so x is the same thing though. So the two answers you get here, so right, this is x. Y equals x. Okay, so -1 plus I square root 7 over 2. -1 plus I square root 7 over 2, comma, -1 minus I square root 7 over 2. -1 minus I square root 7 over 2. Ta-da! Okay. So meaning to say that you can have complex answers. All right. They're fine. You should just be able to answer them like everywhere else. That just means that if you actually draw these things, right? Because remember, we're finding when lines cross whenever we solve a system. That just means these two things actually never cross because they cross at like this imaginary point. Okay. But that's it for this section. It's probably honestly the most difficult section of the entire class because like every problem is unique, right? You kind of just have to stare at it and decide what's the best course of action. Should you eliminate? Should you substitute? Should you eliminate first and then substitute, right? And then you have to keep track of these pairs, right? Because right, if I flip this, right, if I accidentally put 0, 8, that's not an answer, right? Or 6, -10. Okay. So hopefully you get this. Maybe it would be good to look at the typed notes version of this section too. But that's it for this section. See you guys in the other section.